Okay, so we are one day down in what would appear to be a pivot to
Hmm.
Codex. Things are looking good, and I'll tell you why. I managed to. I've been poking through the code base and the pull requests and issues from Codex. It's very active, so like there's commits from what I believe are OpenAI staff members, commits like every couple of hours. So people are like, this is what they're doing as a job.
Mm.
Um, and they have. I had implemented web search because I was like, man, I can't live without this thing's worthless without web search.
Hmm.
But as you'll see in the bottom right there, can you read the screen or do you need a bump?
Yeah,
One
bump
bump.
will be useful. Yeah, just one.
There you go. How's that?
Yeah, cool. Yeah.
Um, so they I'd implemented web search. Then turns out that the latest version that hasn't been released yet also supports web search. And as you can see from the bottom right here, there's web searches going on now. Um, so I believe that Codex can be our daily driver because it's GPT 5 with file system plus Linux tools plus MCP tool compatibility plus web search. And I'm like, what do we need? Like, that's kind of the whole shebang.
Uh, sort of is. Um,
So, um, where I got to was I'm kind of wondering what's the point of Artifact, which I often do, right? I'm like, this thing's the shit, and then I'm like, why is this even here? And it's not very helpful, so I was just hoping to go through that with you because it's a bit of a pain.
well, what's the? I guess the question is, what's the overlap? Is there anything that Codex doesn't do that Artifact does do? Do we lose anything in terms of future?
Well,
Is there anything we gain
man.
anything in terms of now? Well, we do gain because we get someone else to code it.
Mm.
Um,
Oh, hang on. Can I, before we do any of that, can we have a
mhm.
name session? Which is
uh,
always our
yes.
favorite time.
Yeah.
Um, this the Codex unit, like a running instance of Codex, it's really hard not to call it an agent because it just sort of flows so naturally.
Uh-huh.
Um, I had thought of calling it worker, but I think agent is the more natural thing. Agent is what OpenAI call it. It feels like an agent in a lot of ways, but it's not a free agent, which I think is really what we're talking about at that top level.
For the long running agents
Well,
or
the
the human
indefinitely
agents.
running, the non continuous, unlimited time thing that can interact at our level. Like it's these agents only interact at the file system, the Git, the machine level. They are mechanical or machine agents. But
Uh-huh.
when they're bundled together as an actor, then they become something a little bit more than just an agent. They become like I don't know what you call that, but a free agent, maybe.
So we got a hierarchy here, haven't we? I like free agent, by the way, just as a term,
Hmm.
because that leaves up one level down to be agents that
Yeah,
are not free. And we don't need to
right.
add
These things
order
are
agents.
absolutely not free. They are highly constrained.
Yeah,
They are sandbox. They are limited. They do what you tell them and nothing more.
yeah,
They're treated as disposable. They can be forked whereas a free agent can't really be forked. You know, like its identity is unique, whereas an agent is copyable, clonable.
Right, right, exactly. Now, so how about this as a start for 10? So free agents are any humans or um, AIs that have got the same, work on the same level as humans.
Yeah,
Um, and
yeah,
agents are the at-rest bundles that we were talking about the other day,
right.
and the running version, the instantiation of an agent is a bot.
I think we need to ditch bot because bot doesn't seem to.
Oh, I quite like it. It's just
Yeah, I know you
it's a
do, and I
it's a
do
nice
too.
word to say. It's like
I know, but maybe
bot.
it's like you know, a colloquial kind of a generic contextless term that we can just chuck around on occasion. But if we deal with our specific dictionary,
Yeah, so we still need the name for the right hand side instantiation running of an agent,
well,
which
no, that's
the
what. Well, an
the
agent image. So we've had this debate before about images versus the running thing,
yeah.
and so there is this whole concept of you need to be able to search for agent images, but then you need to be able to run an instance of that image, and when it's running, it's an agent.
Okay.
The
Uh,
image is like the
I like agent image
yeah, an
because
image.
in VMworld, everyone will get what an image is.
Yeah, well, we're at that level. It's literally an image of um, everything you need to run the Docker container, which runs as the virtual machine. It runs as a virtual machine. An agent is a running virtual machine. The agent
Right.
image is what you booted or configured the container, the virtual machine from.
Okay, and that's good because we've got the word agent throughout there, which um, identifies them as a similar thing, just running at different levels or in different
Well, at different
states.
at different life cycles. Like the
Yeah,
image is pre-boot. Um,
yeah. So if we go for agent image, is the at rest um, VM style image.
yep.
An agent is the running instantiation of an agent image, and a free agent is a human like long running grinding agent that is not well, it is a type of agent, but agents are what's the difference
Mm.
between a free agent and an agent if we're talking about an AI is the fact that you're spinning up an agent image to do a piece of work and then that's it. You know, you can take a snapshot
we
of it.
could be really cheeky here, Maxwell.
Yeah.
We could call that thing an AGI because you say makes right.
Yeah, we could, but that is just going to add in all sorts of
It makes it.
cloudiness.
It fits the model. It's general. It calls on these agents.
Yeah, but it's claiming it's that's too charged for me. That's too charged up.
Okay, all right.
uh,
Just to chuck in another issue, another naming issue for us, we also need to deal with agent snapshots because I'll tell you what I think a snapshot is and how the user interface goes for the whole system.
okay.
So this is I like this, but you might. Whoa, hey, we don't really need to be hearing about all that now, do we? So we need to. What's an easier way to do this? Fuck. Man, I don't think I've ever heard you yawn. Am I that boring? I'm getting there, right? I'm just trying to fucking load this thing up.
Yeah, hurry up, would you? Yeah.
No, that's bad too. Okay, so we'll stick with ChatGPT. The way I think that it should work now is that we still have this button down the side, which is really just starting a chat with a pre-selected agent, so they're like shortcuts.
Starting a chat would be the equivalent of selecting an agent image and then creating an image, a running instance.
And running it, yeah.
Yeah. Okay. So
Yep.
it's searching for and selecting an agent image.
And what I think
going
what I think the chats become, these are the agent snapshots.
Yes. Yes, because you on the flow, you're taking an image, spinning it up into an agent, and as soon as you interact with it, it's got a thread, and so it's something different from that initial spin up.
Yeah.
And now you got a snapshot.
It's got some state, and that's the snapshot, or it's like the frozen state. Because what you should see is if these are all of your each one is a chat with an agent, and so you should be able to see the status of each one. Some will be running, some will be paused. You can delete them. Some can be forked.
Right.
You can point at them and use them as context. You can treat them like objects that can be read from. They contain the execution history of what the agent did while it was alive.
So if you take an image, create an agent, the very first time you interact with it, it becomes a snapshot. If we're snapshotting it every
as soon as you boot
prompt.
as soon as you boot it, it becomes a snapshot.
Right.
Because it boots, it does some stuff, and then it pauses and waits for your. That's the discontinuity part. It pauses, it halts.
Okay.
An agent always halts, but this higher level thing, an AGI, never halts.
Yes. So the free agent, I do like that term.
The free agent is continuous.
Can receive, after you've closed down your portal, you've gone off for your dinner, it can receive events that will generate work.
Yeah, but I mean, the issue is that an agent can do the same too. Like an agent can await a notification, which could just be a tick of the clock. Like every morning, an agent fires up and goes, "Hey." I think we always fall down a hole when we try and describe what this top level thing is, and maybe we can just leave it because we don't need to define it now. We're trying to name the components.
So why do we need? We've got agent images and we've got agent snapshots. Why do we need agents as a term?
Yeah, that's a good question. Because the agent it's easier to refer to it when you're talking about it. You're like, fire up an agent. You're not like, fire up an image and then take a snapshot. Like, you don't want to say that. You just want to say, start an agent.
Mm-hmm.
Make an agent. Like, maybe it's easier to think that, like, those are just states that an agent can be in. Like, image is pre-birth. Running is an agent. And a snapshot is when it halts, that's a snapshot. But any of those things, it's okay to call it an agent. It is an agent, it's just at a different life cycle.
Mm-hmm. Okay, so when it halts, it's a snapshot because it's at rest, but it's at
Yeah,
rest with context.
yeah, but in practice, it can be at rest momentarily, and then it carries on. Like it can like work, 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 snapshot, carry on working as well.
Yep, true. And I'm thinking in UI terms now. So they call them chats. What would a chat in that naming structure be?
A chat is the message history of the interactions of a particular agent. That may not be your interactions. It could have been interactions from external systems, but it's the turns of the agent, the tasks that the agent has worked on.
So that sounds very similar to snapshots.
Well, maybe. Um, yeah.
So agent images, and to fall in line with the rest of the world, we call them agent images and agent chats, where agent chats are what we're calling
Oh, right. So
snapshots.
the agent chat is like the thing. It's like the chat history.
Yeah, it's the running state of an instantiated image,
Okay.
agent image.
All right.
Um, and the long running thing, um, maybe that's just an agent chat that's still going in the background.
Maybe it doesn't matter to give it a distinction.
Yeah, that's what I'm thinking. Why did we think that it was? Because we wanted to have these background grinder um, free agent types as opposed to anything that's stopped. But as you just quite rightly pointed out, they could stop momentarily and then
Yeah.
boot back up and
Yeah.
receive more information and so on. And so maybe that distinction is not helpful. We could remove that definition.
Hmm. Maybe.
Um, so we'd have agent images and agent chats. So you'd search in terms of the. Can you go back to the UI? Um, let's see how that fits. So where would you go to spin up an agent image? Previously, it was a repo.
Discover. So there's a pre-provisioned agent that you can either start a new chat with or continue any of your old ones, that is used to discover um, agent images. And I don't know why it seems like it could just discover agent chats as well. Like you can find a
I
new
agree.
agent or you can carry on with something else.
I agree. Now, one of my main beefs with the whole chats thing, as I was saying, is the auto-generated long list is not very helpful. Because it just you end up, as I saw you there, hunting and pecking
Yeah.
up and down. So if you go to discover, it's like maybe there's a top level section with images which are just clean, done
Yeah.
anything with them, and then below that there's a bunch of agent chats and they're not clean. Some of them are still running, but you can jump into them and then interact with them as well. If they were stopped, then they're exactly the same as chats. If they're running, then you just jump in and see, where it's got to. Maybe you can interrupt it. Maybe you can add new information. Maybe you just want to check them out. Yeah, I think we can. Unfortunately, I think we can get rid of free agent. I quite like that term. But
Well, I don't think we need to because it's just that we're not at the level yet that we need to. Like we're not at. We can't make a free agent yet. So
yeah,
We don't need to define it one way or another.
Yeah.
So this concept kind of dies, right? The big long
Uh,
thread.
the big long thread, isn't that just part of an agent chat?
Well, no, because this was swapping in and out. Oh, you're saying that this is actually a fuck. So what happens when you got a chat where you swapped? The agent was swapped out partway through because a better one.
No, I don't.
Oh god. We have
That
like
was
all the pieces, but they don't quite fit nicely. They come out
well.
always with a wrinkle.
It's distinctly different, though, isn't it? Because this is a conversation. This is like a conversation between one or more bots, as opposed to um, conversation is definitely not the right word, but a
Well,
chat
maybe that,
is a
maybe
discourse.
this is actually what it is. Like if you took this thread and you said collapse it all, then this would look like the Chat GPT list of chats,
Mm-hmm.
perhaps, or like your emails, for example.
Mm-hmm.
And but
Um,
when you click on each one, you can either resume that one
well,
or
it's closer to an email thread, isn't it? Because you could have half a dozen people in an email thread.
yeah, and then you switch people in
And
and
then,
out and
yeah,
whatever.
go up and down and saying what
Forward this to that,
Bob say,
BCC this.
yeah. Um,
I
this is
think
something distinctly different. This does warrant a name. Um, hmm. What's what's the difference between a discussion between two people and a discussion between many people? What's the wording for that?
discussion between two versus a discussion between more than two. I guess one's direct and the other one is group. When you got three
Yeah.
or more is group.
So this is like a group chat, right?
Well, no, because you had a direct chat with one agent at a time.
Um, sure. It could also be that the router or orchestrator decides to swap one bot out for another.
Yep.
And so there's a conversation between the orchestrator and the new bot. It's like,
Right, but
you
that
look
you're
very,
not party to that, so that's just happening in the background. So that's not any of your business.
true, true.
Maxwell, this sucks.
It does.
We're always like the amount of times we've been like, how do we put these bits together? We know how it fits together logically, but
Well, we can see it. It's just getting a good set of names around it will help immensely. Um,
immensely.
uh, how about this? So we have agent images, and we have agents, and we have chats. And the chats are the screen we're looking at the moment.
Okay, so
Um,
an agent can be a chat is an interaction with one or more agents in turn,
yep.
always in
And
turn.
yes, and images are as previously discussed, and
Yep,
agents are as previously discussed.
yep. All right, that sounds good to me.
Okay,
We
right.
good with that? Okay, how do I write it down?
Yeah. Uh,
Agent images.
Agent images are the uh, at rest static files that can be instantiated into agents.
Okay,
Uh,
agents.
Agents are the running instantiation of an agent image.
It's a little bit circular there.
A little bit, but no, it's not too bad because it is kind of where it is, and a chat is an interaction between agents.
And what, sorry?
A chat is an interaction between agents.
Like that?
Yeah.
Okay.
Right.
Well, let's just run with that until it breaks. Now, the UI, still looking to target this model then, where we have a long-running chat where each segment, each leg is with a specific agent.
Yes.
And you switch between them depending on task and what you're trying to do and all that.
Yeah. Yeah.
Yeah.
So you bring in different experts with context saying, okay, I'm going to bring in this guy who is aware of the previous bits of the chat, these boxes.
Yep.
So you bring,
I think that we should use these bots to figure out how to solve this problem we have, because it feels like we for sure have all the components that we need. We are struggling with arranging them and balancing the names and definitions around the place and laying out the UI. But if we can get Codex up to grind on this problem, then it can at least do a lot of this reconciliation and hole finding, gap finding for us. And I don't think that's a cop out. I think that's a legitimate use of the tool. And so,
Yeah,
do you
I think
agree
so.
that it could solve that problem?
Yeah. To get a coherent namespace? Yeah. Probably.
Yeah, and a geometric design for a
Yeah.
web app.
So, but the concepts are right. Images, running instances being agents, and what we're looking at here as a chat. Each of those seem necessary. And so, again, back to the discovery thing, it's like, okay, I want to discover.
Right. Yeah. So the action that you want to do, the thing you want to do, is legit. Like that. There's no mistaking that that's a thing you need to do.
Yeah.
It's just our question is, where is it arranged on an app? How does it fit into the namespace? All that. I believe that we can do something akin to the reasoning folder that we used to have that can whir away and design all that for us. If you agree on that, then we only need to skim this enough so that you and I can talk about it, and then we can just talk about it enough to get the system up and then use the system to solve these things.
Yeah, I agree.
Yeah.
And
I have never felt closer to having a working AI system as today. Like I can feel it.
Yeah.
It's coming. Like it's real. It's like in hand practically. Like this thing here. I don't know why so the web's got problems, whatever. But
Right.
the fact that it can just whir away, and see here it was solving this was a problem of how do I lay out the apps? What's the architecture of configuring Fly.io, right?
Mm-hmm.
So they're all just problems that, if you frame the problem right and allow the bot to loop over it many times, you'll get the best answer. There's just no there is a best answer, or there's a handful to pick from, and then you're just picking from really good answers.
I've got a UI ask.
Yeah.
Sorry. I'm just thinking how I would use this. It's like discovery, absolutely. That's the start of the task. Or, you going back into a task. I probably also want to see recents, so I don't need to necessarily go into discovery each time. So, like, what was the last thing you're working on? But I might need to go and discover something I was doing 6 months ago. The other thing I'd be interested in is seeing um, running agents or running chats.
Yeah. So why don't we make it so that you can access all that stuff in band in chat first, and
Mm-hmm.
then we'll figure out how to lay it out into a UI.
Yeah, yeah. So, in terms of a CLI, to get simple about it, um, I want to do like a PS minus UX in order to see the running things equivalent. Um, I'd want to see history, and I'd want to see the files and folders. So that would
Yeah.
be sort of the equivalent.
Yeah.
Okay.
Yeah, I'm still not 100% sure how to lay that all out, but um, helpfully, the Codex guys are working on a pull request right now that is about having multiple agents, and so they have to deal with a lot of that UI stuff. So I don't know what that looks like right now, but
Mm.
this is their work making achieving this goal. So they're starting with a code review agent, and they call them sub agents, where a running agent spawns a specialized agent that's good at doing a particular type of job, which is
Okay.
exactly what we're talking about.
It is. I don't think they need to specify sub agent as a
Well, their
separate
issue
thing.
is that they have to deal with all this in the one user interface, whereas
Right.
we get to explode out because they have to make it run on one computer, but we're exploding out to like unlimited computers.
Yeah. Yeah. Okay. Well, let's see what they come back with.
Yeah.
Let them do the work.
Well, that's the thing. Like, we're writing this project, and it's looking like it's gonna be a good ride. It's this guy and a bunch of other guys.
He looks very happy.
He does. I bet he gets paid handsomely.
I bet he's also not that happy in real life right now.
Who is though? Oh shit. Okay, so that's sub agents. Clearly, we still have some layout issues that we'll get around.
Mm.
We got the names sorted enough. We'll make a solver to reason through all these things, and you can put in your UI requests, and we can see where they shake out or lay down. I'll build the logical backend as best I can. Shall I go through that design with you?
Yeah. Yeah.
All right, so do I dare do a whiteboard? Oh, we all love a good whiteboard, don't we?
Yeah.
We really do.
What I really need with a whiteboard is that laser pointer.
Oh,
Someone fucking build me a laser pointer. It's not much to ask for.
it isn't. It really isn't. All right. Prepare to have your sensibilities offended by mine art.
Oh. By Jane Austen.
Oh, crumbs.
You alright?
I'm not sure I am. But anyway, the show must go on. Right. So, somewhere out here we got Artifact.
Yeah.
That's your authentication who the fuck are you? What are you doing? What's your bank balance? All that. That's basically the Git. That's the database, effectively the database and the business logic. So very tiny little naps,
Yep.
macaps that just do little tiny calculations. All right. Then at some point, something or other happens pretty early on, actually, and it goes, I need an agent.
Mm-hmm.
And so do I have more freaking shapes than just a. Is this it? These are all the shapes I get.
Yeah. Oh, you got lots of colours though.
I don't want.
Change colour.
I'm fucking colorblind. I don't need a fucking. Come on. Alright, I'll take that. Oh, God. None of those are what I wanted. At some point, it
Your
goes, I
phone.
need an agent.
Okay.
Oh, dear. Let's go. Fail. Okay, abandon. And so this is the contentious idea that I have, right?
Mm-hmm.
Fly.io has a wonderful MCP implementation that can let you do absolutely everything possible with their infrastructure.
Mm-hmm.
And so, what I want to do is fire up a very special Codex container that has the credentials for our Fly.io infrastructure. And when you come in, like, let's say you're a new user, you turn up and you're like, you sign in or you indicate somehow that you'd like to have your own workspace, your own
Mm-hmm.
place, as it were. This agent is a Codex agent, and it receives the request from Artifact that would have been a set of carefully worded strings like
Mm-hmm.
make a new user. The user's ID is blah blah blah.
Mm-hmm.
The blah 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 type of image to use is blah blah. So whatever options are discernible here, it sends the message in plain text to this agent,
Mm-hmm.
which begins whirring away, and it goes blah 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 blah, and it makes some infrastructure.
Mm-hmm.
In this case, the infrastructure is a brand new Fly app. So a Fly app in Fly terms is like a web app would be considered one Fly app.
Okay.
Fly's recommended architecture is a little bit different to how these things are normally done, but they recommend making one dedicated app per user. And what that means is that, like, you'd sign up, I'd make you a new Fly.io app, and then inside that app, you can do anything you want, sort of thing.
Oh, okay.
So that makes it easy for us to handle your billing.
It's like my personal space.
Yeah. And the good thing about that is that if you want to take it with you, Fly lets you transfer it to another Fly account. So you might join our account and we make this app for you. And then you're like, oh, I'm a big boy now. I want to go play on my own. And then you go set up a Fly account of your own. And then we just move the whole app over and now it's yours. And we're like, good luck.
Mm-hmm.
But also you can do things like keep secrets. So like API keys and credentials that are all like local to you and only you.
Mm-hmm.
And
Mm-hmm.
that's quite a good way of doing multi-tenant in Flyland, is to just
So
make an
I
app.
had a small organization of four people. One was the super admin, and the other three were users. What would be
Yeah.
the structure?
You would make yourself an org in Fly.
Mm.
This is probably kind of important, so I'll show you. So orgs, you can set up. You'd make yourself a new org called like super private,
Yeah.
and in an org you can actually add your own credentials and stuff, your credit card and whatnot.
Mm-hmm.
Which I won't do, but
Yeah.
it
Yeah.
makes it an independent legal entity sort of thing from the point of view of Stripe. Okay, and then inside that org, I would make one app per user.
Right. Okay. And then that, as a user, if I have a mix of my own stuff and the org stuff,
The data or the agents or the what's been mixed?
what's been mixed is I want, so I've created my personal Fly app. Inside of that Fly app, I can do anything.
Yeah.
The two things I want to do is to get a recipe app and access to whatever the org has given me access to.
Okay. Not seeing the question.
Is it possible?
Well, yeah.
This architecture.
Yeah.
Yeah. Okay. Because really, what you've got there is RBACs. So and
well,
mixing
each
that.
app, each Fly app is sort of like it's basically a dedicated server cluster with network and storage and all that, and you can do as you wish with it, including talk to other apps over the network. But
Okay.
all of those interactions are subject to the same authentication.
Okay, right. So I've got a single sign-on, and inside of my Fly app, if I'm being given permissions from an org, then that comes inside of my Fly app, and it deals with the interaction between that. A bit like getting, I got my Google Drive, you've got your Google Drive. You create a file, give me permissions.
Yeah, it's exactly that.
For one file.
Yeah.
Okay.
Yeah.
All right, good.
Except for us, it's not in one umbrella. It's legitimately across the internet, like the good old days.
Yeah.
That's the key difference. It's not a walled garden. It's the internet.
Good. All right. Yep. Okay.
Okay. So inside of Fly, so normally you make an app per sort of project, but for us, we'd make one app per user. Inside of an app, you get to see things like what the IP address of the machines are, how many machines you have. So here I've only got one, but you would have like maybe 10 or 20, depending on how many chats you had going at the time. You would check your logs, whatever. Typically, people wouldn't go in here. However, we can, the same way that we had this special agent that could control the Fly infrastructure, we can give each user their own agent that controls their Fly infrastructure within the bounds that Fly has set. So it's like you can get like keys that are for, just for that app. And so we can grant you, basically we would give you the same infrastructure management agent that we had, but it's just scoped down to just your infrastructure, because I don't know why not. Like,
yeah.
And then you ask for stuff and you want it reconfigured, the default one's going to refuse to do things that are bad, but the point is, it's still like it's there for you to chat with. You're like, where is my server? Oh, it's here. Where's that on a map? Oh, here we go. Those kinds of things.
Yeah. Yeah.
What's my cost? How can I get the pricing down? All that.
Yeah.
And so this raises an interesting concept, really, which is to say that in this model, a lot of user interactions might as well, or a lot of infrastructure interactions might as well have an AI in the loop, where the AI receives predetermined strings that tell it to do things, and obviously we test and evaluate the agent, but it's just simpler to use our unit of agency to do these jobs rather than writing custom programs.
Yes.
Because it's starting to feel like the eval is the program, not you run the eval and then you produce the program. It's like we are doing continuous evals all the time with a bot managing the improvement based on evals. And so that means that in a continually adaptive system, you kind of want it to be all agents all the way down. And in terms of latency, like some of those outputs from Cerebras that were like 3,000 tokens a second, like that's faster than a call to an S3 bucket.
Yeah, I see that. Okay, good.
So the model was going to be that I'll start with one standard codex image, but we can produce other flavors that are useful for different things, like different programming languages, or it's got different tool sets included, or whatever. But it's pretty useful right now to just have one. And then when you first sign up, you will be connected to the hosting agent that's going to treat you like someone it doesn't know, but it will do this one favor for you, which is to set up your own app. When you're interacting with it, instead of just seeing this blind progress bar, you would see the internal chat of the hosting agent whirring away, working through provisioning your infrastructure for you. And then at the end, it's like, okay, done. And then then you now have your own agent down here somewhere. And then your session gets handed off. You can't talk to this one anymore because its job is done. But just like in this situation, this was the provisioning agent. It was like, blah, blah, made you this, made you that. Your name's this. Here you go. Passing keys over to your own infrastructure manager. And now you can't talk to this one anymore. You can see what it did, but it won't accept any more talk from you because you got your own stuff. You don't need to talk to it anymore.
So your focus is on there, but can you pop up back to the provisioning agent and say, I can't change my credit card?
You would be dealing with your one to do that.
Oh, okay. All right. Right. So that is a single use pop up, the one at the top.
It's like a
pop up.
Yeah, it's the one that we run because we hold it holds our fly.io key. Like it contains the admin key.
Yeah. Okay.
And so we don't really want you talking to that too much, except for doing this one narrow task, which is setting up your infrastructure. Then you carry on talking to your infrastructure.
Got it. And then it's effectively burned. But then the one at the bottom is the one that you talk to change your credit card.
Yeah, because like you don't need to talk to us anymore at that level. you are now in the system.
Yeah. Yeah.
So when you first come to our site, you'd be chatting to like over here would be oh
Well,
god.
it's an installer effectively.
Yeah, but here's like the sales pitch, right? The sales agent, and you're like, hey, what's this thing? And it's like, oh, well, it's the best thing ever, and it's
Mm.
so cheap, like, but you do need a credit card, blah, blah, blah. And then at some point, you're like, okay, I want it, make it happen. And then
Mm.
this thing hands over to this thing, which is like the grumpy IT admin guy that stinks. And then you see its chat happening. It's like blah 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 blah. Standby, provisioning server. It sees your region that you came in. It's like, oh, you're closest to Tokyo. Okay, we're provisioning a base agent in Tokyo for you. This is the entry point to your app, and then it's like hardwired so that next time you sign in and try to talk to the welcoming committee, it
Mm.
repoints you to your own infrastructure.
Mm.
And there's always like this one agent that's always there to welcome you. Like that starts up as soon as you do anything. But this now is the agent that produces all the other agents of yours.
Yep.
So it's like you really only have this one. All these agents are children of this one.
Yeah. So just to check my understanding of this, which I think is right, it would be the equivalent of you making a decision to install VMware, um, and there is a process to go through in order to get your hypervisor, and then you create a whole bunch of VMs inside of that hypervisor. But after the hypervisor has been installed, you don't need to go back and talk to the installer anymore. That package is done.
Well,
It's done
yeah,
its work.
and yeah, that's right, that's right. And like, why would you? Or yeah, like maybe another way to think about it is like this: you talk to this to get your bare metal box, and then it provisions your bare metal box and installs your hypervisor on it, and then passes you your hypervisor, and now you use your hypervisor to spawn VMs.
Yeah.
And now, depending on how you permission those VMs, they can't talk. They don't even know that they're in a VM because they can't talk up unless you allow them.
Mm.
But from here on in, this is your hypervisor, and these are your virtual machines.
Yeah. Yeah. That works.
And
And
so,
your
yeah,
hypervisor can then deal with, things like, where you want these things to run, how much is are you running up,
yeah. Like, what's your
all that.
spin? When do I need a new one? Oh, there was an error. What do I do when I get this error from Fly? Okay, let me search the web. Okay, it's probably this. All right, that's out of bounds for me, but I got this other fix. Just tell the user that probably it'll be a little while, or we're gonna move regions. It'll make you feel like you're in control and the system is talking to you, because typically you use any of these apps and you're like, where is the infrastructure? Whose is it on? How can I see what's happening? What if I want to tune it? And then you only get config options that the vendor paid some software devs to give to you after how like a committee and how much cost, which is all built into the fee you pay. But for us, we're launching Fluid. We're like, we can do literally anything, but it's an AI. So,
Right. And that purple box at the bottom would be the one who um, understands, say, if Fly brings on our provision a new area which is closer to you, the latency is
yeah,
lower.
yeah,
It's like, hey, there's a new thing here. Do you want to
Yeah.
move from Tokyo down to Singapore?
Yeah, that's right. That's the thing.
Yeah. Okay.
And so then when you're chatting, if you ever call upon or need a new agent, this is the thing that makes it. And it makes it by talking to Fly's infrastructure to create the machine for you and boot it. Like, that's what kicking off the agent does.
So if I'm in Discovery, am I talking to that bottom purple one?
No, you're talking to one of these ones, which is provisioned as the Discovery agent. This is the infrastructure agent.
So say if I went to spin up a new agent from an agent image,
Yep.
what would be the path?
After Discovery?
So Discovery, where your cursor is now.
Yeah.
So it's like, yep, that's the
Maybe.
image.
Yep.
I want one of those.
Okay, so you would go, you'd make a privilege call out to this guy, and you'd be like, this image configured in this way with these parameters, give me. And it would then make you one like that.
Mhm.
And now you would have that's your child.
Yep. Yep.
When
So
you're
that-
in there and you go, like when the user somehow says, I need a new peer, that's when it goes up, and then this one makes a child.
Got it. So the green box that deals with discovery and it's like, yeah, I'd like one of those and so on is that parent green box.
Yep.
And it would ask the purple box here, okay, users just asked for this. And it's like, fine, here it is.
I would name that the host agent.
Yeah.
Because that's the thing that hosts everything. It handles the actual metal.
Right. And you've got 3 in a line there.
Yeah.
I can see the 2 in serial, but the 2 parallel ones would seem to be children of
The host?
No, one down, the green one.
This one?
No, one up. That one, because that feels like the UI, and then from there, we were talking the other day about having a fairly flat structure where you can go up, down, load. Oh man, you got hay fever or you're getting ill or something.
Yeah, I know.
So it seems like there is a privileged green box which encapsulates your effectively your UI. That's the thing that you go to before jumping into a sub job, but you can have many sub jobs or sub agents.
I'm not quite sure I get what you mean. Like, these ones would be like, one would be the discovery, one might be the group chat agent, one might be the coding agent.
Okay, so which is the agent that deals with? Oh, actually, no, you're right. 2 seconds. All right, so
sometimes they
from the
need children
host.
to do their job,
Yeah,
but other times they need a peer because they don't want to control the thing. They're helping the user achieve something, so they spawn a peer and then hand over the user to the peer.
so if I wanted to run discovery, there's an image. Okay.
Yep.
I want to take that agent image and make it into an agent. and then I
Yeah.
want to interact with that agent.
Yeah. Now, do you want the agent to be a child or a peer?
Um, I don't care. I've gone into Discovery and found it.
Like, do you
As a
want
user,
to?
I don't care. Um, so you've gone into Discovery, you found it, go,
You probably want
okay,
it as a peer then, because you just start a new chat with that agent. Whereas if it spawns as a child, it's being used as a worker by this agent. This agent
hmm
is using this one to get some job done for it. But at this level, you these guys answer direct to the user. These guys the user can drill down into, but they are primarily set up in service of their parent. These ones are set up in service of the user.
okay,
So the human comes in and interacts here, and then these ones manage and corral large fleets of children underneath them to get the work done that the human wanted.
okay, yeah, yeah. So
Does that sound alright?
it does. So I'd still go through an agent, which is effectively um, my top level UI. And say if I wanted to go to previous chat, discover the previous chat, it's like okay,
Yeah. So
spin that.
one of these agents might be operator, and it can hand you off to other peers.
Right. That's the thing I'm getting at is
Yeah.
uh, the purple thing is not the operator. It's just
The purple
purely
thing is there to provision the agents because that's a pretty complicated job. It responds to whatever the top level agents tell it. Like the top level agents are created by default and by the user, and they serve the user. And they can talk to the purple one on behalf of the user. Uh, the operator could even hand off to this one so the user can talk to it directly, maybe. But in order to get their job done, sometimes these ones need to talk to the purple one, depending on how it's been configured, because they might want, like, this one needed a child, so it's like, hey, I need a child, make it happen, and it's like, oh yeah, okay, cool.
right. So
Because they're all flat. They're all flat from Fly's point of view. They're all flat. They're all a dedicated virtual machine.
yeah,
But how they are controlled is how the topology is laid out is very much dependent on our internal configuration.
yeah. Okay. So if I wanted to do that route where I want to spin up an image or find a previous chat that's been stored in disk, there would be one of those top level human interaction green boxes.
Yep.
I would go to that
Yep.
and I would say, right, spin up me this image.
Spin up me this image. Yep.
And it will go to purple and it'll go, right, you are. Here it is.
Yep.
And then a new green box would appear, and that's say, I don't know, my weather app.
Yep.
And then I'll go down and talk to that weather app. It's still at that top level because it's a human interaction thing, and I ask it something it can't do. Figure out what the correct ambient temperature should be before you can create Lamrog and Josh, and might need a child app to do that.
Yep.
So it would ask for the provisioning of the purple thing, and I'll go and do it. I wouldn't. I could go down and talk to Lamrog and Josh, but I wouldn't know anything about weather because weather
Yep.
is now the weather stroke Lamrog and Josh app.
Yep.
It's got more skill. Okay. And does the hierarchy stop at that point? So can children spawn new children?
It goes on forever.
Okay.
Obviously, I think there's some safeguards you want to put in there, like specifying maximum depth for any given task, but realistically, it goes across forever and it goes down forever so long as you've got the money to keep paying. But you only really have to pay for what's running, because as soon as they stop, they can be deleted, and then it's just down to the snapshot being used to restore them.
Well, yeah, absolutely.
So
Um,
you'd probably, at tops, you'd have like 50 running at any given time, max, I'd say.
yeah, yeah,
And if you ran those constantly all month on Fly, you'd probably only get a bill of like $100 or something.
yeah, and everything else is just disk space, so you could have. Uh,
Yeah, so I mean, and obviously there's room for efficiency and compaction and all those types of good things, but I just figured that this, if we can just get this topology right, then we can use this machine to solve
mhm,
our problems. Like, that's what I'm excited about, is that as crude as my first pass is at this and inefficient and lacking some answers like UI layouts and all that, I feel like it's got enough skill that it can be set up to repeatedly loop in search of answers and to reconcile endlessly across a code base or even just some spec documents.
yeah, yeah.
And that's kind of all we need. Something to
So,
tell us the answers.
um, yes, I agree. I'm just trying to think what a session would look like. So when I log in after a period of time away,
Yeah.
what am I logging into? What's my first, you know, flashing cursor?
Your
What
preamble is talking to the front of house agents
no,
that
no.
we run.
So sorry. After provision. So
Yeah,
I've
no.
done
Even
all.
when you come back, and then
Uh
they'll convince you to start the login loop,
huh.
and then you'll log in, and we'll realize, you sir, yes, we have your infrastructure over here, and then you get repointed down to here.
Okay. Where's here? Is it us?
All this stuff. This is you.
Yeah, but specifically, where's the blinking cursor? Who am I talking to when I
Well,
log
it's
in?
who you're talking to last. So that's the state of your. So these things are ultimately controlled by or registered with Artifact. These are held in a proc tree. They look a lot like, for each given repo, they look a lot like that, the proc tree.
Mm-hmm.
And then you can sort of see which processes there are. Some of them are live, like containers, but others are dormant. And Artifact stores for you where you were last, what the last state you were in was. And then depending on what you do next, you're like, hey, where's my Lamborghini Josh? That will have a pointer to a particular frozen or snapshotted agent whose container may or may not have been scavenged. And either way, you get the container back exactly as you left it from the snapshot, and that's your blinking cursor. And off you go. It's restored. Happy days.
Okay. Okay. That seems to work. So you get that means I might have been talking about route mapping or camping last time.
Right.
I'll log back in, and I'm back in the camping app,
Yeah, you're back exactly where you left. Yeah.
and then I say, "Where's my Lamrog and Josh?" And so there's
And then an agent goes off and tries to
well,
serve you.
it would know about discovery, and discovery will
Yeah,
go.
and it knows about. It can
Hey,
see all the frozen states, it can see all the snapshots, so it can go through uh, the other chats that are in
yeah.
progress, and it can see the chat history, so it can search that.
So there's certain functions that every app would need to do. It would need to recognize if I'm talking about something else that is actually another app,
What's
and
an
then
app?
switch. Well, like last time I was talking about camping.
Yep.
I jump back into camping. I say, "Where's I want to talk about Lamrock and Josh.
I don't think
Camping.
you shouldn't expect every app to know that. What's better to have is that there's actually another agent running in the background that is trying to think if you might actually mean to change over, and that means that the specialized app can be quite dumb and focused to purpose. It doesn't have to deal with your idiosyncrasies or your switch abilities.
Yeah, which is where operator comes in. We keep on coming back to operator.
Yeah.
Okay.
Or back chat,
Or back chat.
listening in the
Yeah.
background, and then at some point, maybe not straight away. Maybe it takes about a minute for it to realize, and it's like, oh, hang on, he's talking about this other thing, and then it halts that agent, might roll it back, but then flicks over to the other one.
Yeah. Yeah. So that I think the operator's absolutely essential.
But
It's like
that's all prompt engineering right there. So what I'm trying to give you, what I think I'm going to be able to give you, is where you boot an agent, and it's going to start with the repo, the branch, the commit, and maybe a path that you wanted to scope to,
mm,
the user message,
mm,
the sysprompt,
mm,
some config that sets it up, like what tools does it have, what MCP servers does it have, and possibly a tool mapping where you've altered the tool prompts. The config contains where to get the tools from,
yeah,
but
and can
the
change which tools. Yeah.
but the tool prompt mapping is where you've overridden what the text says. So for that particular purpose, you've realized that if you rename this tool the Lamrock and Josh Finder tool rather than search, that makes a better result.
Uh-huh. Okay. And we're still going with the model of constraining which tools an agent.
I think so. Yeah.
Considers.
Yeah. And so, kind of when you're interacting with the fleet, I think you only need these 6. Where you search for agent images, you search for agent snapshots.
Mm.
You can fetch agents so you can learn more about them. You can spawn a new agent. You can, I guess you wouldn't need list if you've already got search, so sorry about that. And resume snapshot. So spawn from an image and resume from a snapshot. And sort of with those 5, that's kind of all the agent management that you need to do, I think.
I think so. I mean, everything else. I mean, there's nicely saying, show me all the running agents. Show me my recents.
Yeah, but that's all.
That's all nice.
That can all be a separate agent too. Actually, like it doesn't need to be this particular agent.
Yeah. Okay.
So it just feels like a lot of the functions are tiny, like very, very tiny. Sorry, the number of functions is very small.
Yeah.
And that's kind of a really good sign, I think.
It is. Is there anything else? So,
and at that point, you would go in there and you would tweak the prompting and the config to make the agent do what you wanted. But because of this hierarchical ability, you'd be able to prompt up an agent that could run evals to change the config of its child slightly each time, so that it could try and it could self-improve the programming of the sysprompt to make the agent more conformant with a particular goal.
Mm-hmm.
And so in this system, I imagine, sure, getting the first ones off the ground manually are going to be a little bit cumbersome, but as soon as we can get that child of a child of a child, that's when you can have bots curating and creating improvements on other bots so that you're like, this is what this bot has to do, and then it just like whirs. Who cares if it takes an hour or two? Who cares if it takes overnight? But it comes back and it's like, look, when we started, we were scoring 46% on this eval, and now we're at 92. Happy days.
Would you ever want to stop an agent or delete an image?
Yeah, totally. You can do that. If it's your image to delete, you can wipe it out.
Is that another primitive, or is that an
No,
agent?
that's just all artifact land, really,
All right.
because it's not what we've introduced here is something that I've sort of tried to sidestep for many years, which is the execution isolation layer. But now it's much better because it's like a bigger unit of compute rather than these tiny little lightweight things, which is problematic for different reasons. But these big heavy things that are very useful is a very good ratio of heaviness to utility, and the isolation boundaries are hard, like they're good, they're solid.
Yeah. Yeah. Okay. Yeah. That works.
Like it's a good balance, I think, this system.
Yeah.
And so these pools, the artifact is still the consensus layer and the data layer for controlling what's happening here.
Mm-hmm.
But these things are prone to failure. It's okay to fail. They are allowed to recover and all that. And artifact just kind of restarts them. So
Yeah. Okay.
I think that's us, dude.
Could how does this work with what we're saying about the virtual data center?
Well, the virtual data center just means that where the metal that supplies the hypervisor lives is just spread around.
Okay, so is that layer level when you don't really need to think about it? It just happens.
Yeah, you just make these little containers. In a way, it's sort of simpler because it's easier to. These are these are like individual VMs, and it
Mm-hmm.
fits nicely within a lot of the hardware encryption boundaries, like the AMD encrypted virtual machine
Mm-hmm.
stuff, because it expects to isolate a virtual machine rather than like isolating a JavaScript function or isolating a Rust function that just got called in a macap. It isolates the whole running container, which is quite a heavy thing.
Mm.
And so it's also long running, which means it's billable. Like it's not just like, oh, you made 2 millionths of a cent today. It's like, no, I ran this thing for like, you know, half an hour. Like that's a reasonable amount of money.
Yeah.
So us as a
Okay.
host, we're effectively just supplying this virtual machine capacity where you can run these virtual machines.
Yeah. Yeah. Okay. Yeah. Yeah. I think it works. At the hosting level, it definitely works. I'm just trying to think about the um.
Well, where does Artifact like fit in? Because Artifact gets greatly diminished in this role because all the execution, it feels like, all the execution is happening within these agents.
Um, Artifact's still required for that bottom purple box, though, isn't it? For
It's
example,
it's
delete.
Yeah, like I
Stop
think
this
it
process.
it
Delete this
manages
image.
the tree and it manages the snapshots of it, but
And operator manages moving it around. So again, on my simplistic thing, I want to see the processes, I want to see the history, and I want to see the file folders, and then I want to be able to move. I know we're not talking about files and folders here, but I want to be able to
Yeah.
move around, and I want to be able to run stuff.
Yeah.
I want to be able to create stuff.
Yeah.
Um, that sounds like that's a purple box thing, isn't it?
I think it. So what I was imagining was that you sort of artifact is out here, and it kind of does all the accounting, and so it knows how to find this box and this box, and so you as the user see this thing, but under the hood, Artifact knows how to get the network connection to this particular VM and give you that bit back. So that's how you see the files and folders of this agent alongside the files and folders of this agent.
Yeah, but I've been thinking about the purple box as a hypervisor.
Yeah.
That's the place I would go to look for my VMs, stop VMs, delete VMs,
Well,
create VMs.
not necessarily. Like, so when you have a hypervisor like ESX, you typically install a hypervisor management system, usually running in a VM on the hypervisor, that is used to coordinate the view between many hypervisors.
Oh, that's true.
And
Which
so Artifact is that.
so Artifact is a green box.
Artifact is fuck. Artifact is running as a green box, but it's not. Its means of communication is not. This is a control lane where like this thing controls that thing. But in Artifact is a green box that is uncontrolled. It runs. It has permanent disk, like it has an SSD attached. These ones don't. They have local storage, sure, but if you reboot the machine, the storage disappears. So Artifact is running in a green box, but it's not. It's not treated the same because it's not controlled in the same way.
So it's a required and don't mess with it green box.
It's a totally separate application that controls this application.
Yeah. So in this, if we're to run with the analogy in hypervisor, so you've got the hypervisor which deals with bare metal provisioning, all that kind of thing. Then you've got a management layer. Without the management layer, you can't actually do anything with an actual hypervisor. That management layer is necessary and is the one that deals with telling the hypervisor what to do.
Yeah.
So it's always got to be there. So there's a specialist thing, and orchestrator, it could be the nice green box that can ask nicely of Artifact to do stuff. It's like I've got a UI run by one of these green boxes that talks to the orchestrator and saying, "Hey, the user's just asked to delete this other app," but it's Artifact that actually does that.
Yeah.
I'm not getting this. This feels there's something odd because what I'm trying to find is so we've got effectively the kernel, purple, and then there's the operating system, which is Artifact.
No, you might have this purple box is still an agent. All that's happened is that when it goes to create a VM, it calls out to the Fly.io infrastructure API, tells it to make it, and then connects in with it.
Okay, so that's like a kernel command.
A system call goes out. Yeah, this one is special because it can make syscalls.
Right. Um, at the so one up from the kernel, the operating system level, feels like what Artifact does. And then
I
you've
feel like
got
these analogies are broken down a lot.
yeah, maybe.
Because
I suspect.
Artifact's not like Artifact does run within a VM, but these are meant to be ephemeral VMs, whereas Artifact is a long, stable VM. If these ones crash, they just get healed. But if Artifact crashes, that's consensus time.
Yeah,
These things
yeah.
don't need consensus because they got Artifact. Artifact handles all that.
This is why I'm thinking about Artifact as the OS. Um, doesn't need to provision anything itself. Just
Yeah,
needs to be able
right.
to
So
ask
these could
for it
be
to be
considered
configured.
like the processes of Artifact. When Artifact wants to execute something, it calls on this group of components.
Yeah, yeah. But if Artifact were to become corrupted for something, the entire thing fails.
Right. But because Artifact is designed to run in consensus, if you had, for example, 3 nodes running in consensus,
Mm-hmm.
each one of them would have their own execution cluster.
Mm-hmm.
Each one would have its own one. And so when they reach consensus, they would reach consensus on the results of what each one's compute cluster came back with.
Yeah, yeah,
Each agent cluster came back with is what they would reach consensus on, but they control this.
yeah. Um, which is fine. That can be abstracted to a single consensus-based compute layer where you only see the apps, even though they're running on in consensus,
Sorry,
effectively on
what's an app again?
uh, green boxes.
The agents.
Yeah. So if you had three instances of Artifact running in consensus,
Yeah.
uh, and they're all running the same agents, and then reaching consensus about what
Yeah.
each
Yeah.
agent is saying,
Yeah.
then you can abstract that. You don't need to know there's three. There might be three. There might be a dozen. Um, at the layer up, there is a consensus agent. That is the result of the consensus of running it multiple times.
Yeah, the unstoppable agent, which is the one that any one of those three could go offline and it would still look like the agent was perfectly fine.
Right. So where I'm getting fuzzy on is, say you've got these three nodes, each of which have got mirrors of each of the agents and running them independently and reaching consensus.
Yeah.
Where in this box diagram is each node?
What? What's a node?
A node being, you just drew one, so you know the three green
Oh, the
circles,
green
and
ones?
then
So like an artifact VM. Oh shit.
you can switch to it. That's fine.
So an artifact VM,
Yep, yep, yep.
they're all running in consensus, right?
Yeah, yeah. So where's those in the block diagram? Where is each of those green blobs?
From Fly.io's point of view, they are running probably right here. Like, from Fly.io's point of view, this would be one thing, one app belonging to one user.
Right. Okay, I think I'm starting to get it now. So the green blob in the if we were to include them in this architecture diagram would be uh, you squish down the amber thing inside of each green blob.
Yeah, because that's what it presents. Like, this is all the components at the virtual machine level. So this is the bit that deals with Git, the data storage, the consensus algorithm, the web connections, and also telling the infrastructure agent to do stuff.
Yeah. Yeah.
But it's still a VM too.
Yes. Yes. It's just nested. So if you took the amber bit,
Yeah,
and I'm not, don't do it. This would be too painful on a whiteboard. But take the amber bit, squish it down, um, copy it 3 times, and put it inside of those 3 blobs.
yeah, yeah. That's really what's going on. Yeah, yeah,
Yeah. Okay. So that's where Artifact lives. Um, in the arrangement of the consensus and uh, terms of I don't know what the right terminology is, but essentially each uh, internally has its own kind of micro universe of which it tries to reach consensus.
yep,
So in terms of the architecture, there's these green blobs which live somewhere, um, and then there's the interaction between the green blobs, which is decentralized and so lives
yep.
everywhere.
That's the consensus mechanism.
Yeah. Okay. All right, that makes sense. So what I was trying to do there is answer your question about do we need Artifact? I think from what you just said, we absolutely do, because otherwise,
Right. That, I guess my question came out wrong then.
Mhm.
MCAPS and that whole MCP piece that I was so excited about, that seems to have vastly degraded or smudged. Because where
um,
is that here?
NCP is uh, it's very like a tool. So in the definition of a green block hexagon, um, we restrict its tooling, and one of those tools could be an NCP server somewhere.
Well, yeah.
So
So Artifact could still be the client of the MCP. Uh, could still be the host of MCP servers, so that when this agent decides it needs to make an MCP call, it actually goes out to Artifact to make that tool call,
yeah,
and it could be doing the tool call in consensus too.
yeah,
That's one option. The other option is to do the MCP calculation inside of this worker, so that it pulls in the
well,
dynamic code.
I guess there'll be two methods there then, NCP in consensus or NCP isolated. Um, in both cases, an NCP call feels a lot like an artifact tool call.
Yeah, I guess it should, strictly speaking, be subjected to consensus to make the MCP call. But then again, like if you're already subjecting the whole agent run to consensus, like is that overkill? Like is that if the agent
Um,
if the agent was subject to consensus at the end, does it matter how that it made tool calls that weren't individually subjected to consensus?
um,
You know what I mean? Like it starts to feel a bit
I,
weak. Like it's
uh,
like, what's it for? This artifact thing. Consensus, yeah, great. Orchestration of the virtual machines, perfect. Holding the front end so that you turn up and it's like got your state, like where were you last time? Okay, great. But what I thought it was going to also be was the MCP host where it holds logic. But now that's, like I guess the MCP host, there's no reason why it has to just be traditional code. It could offer an MCP interface to this whole shebang where you're able to call a remote artifact cluster using MCP as your protocol, and then it kicks off work that agents do.
well, yeah. So that means that the NCP call should be exposed at the green hexagon level, because then it inherits whatever um, decentralized any consensus that you've got. Because maybe, well, you could have consensus between two nodes, or you could have, oh, sorry, two. Um, I don't know what are the green blobs called.
Artifact nodes.
Right. So
Whereas
you could have
these
consensus.
I'd call these agent nodes.
Right. So you could have at simplest, in order to get any kind of consensus, you could get, well, probably three would be the minimum, artifact nodes. So you don't want to. Uh, mm, it is quite tricky, isn't it? Because you're ending up doing consensus on consensus if you're
Yeah, which
not
ain't good.
careful.
It ain't good.
Um,
So I
what
don't
about
know. I
this? What
look
about the statement that an MCP call is exactly the same as any other tool call? Does that hold water?
that's true. Well, moreover, MCP calls are tool calls. That's what in the artifact system as we've been redesigning it over the last few weeks. That's all there was MCP calls. That's
Right. So a tool call is provisioned in a green hexagon, is allowed to make that tool call. Um, it's inside of the amber blob, which
mm,
is inside of the green blob, um, and asks its green blob to execute that tool call. And therefore, if its MCP is the same as a tool call, it should ask the green blob to execute the NCP and then come to consensus in any way that it sees fit. But it doesn't know about the consensus. It just knows about, I've asked it to do this tool call.
yeah. It's still, listen. Maybe the correct way to approach this is that we got we got quite a big win unexpectedly from having this unit of agency.
Mm.
If we provision that, we will have the tools to be able to reason through these types of problems. And I'm just feeling like we're close enough that we can say, look, let's park these hard problems because we can get this agentic system up and then we'll have better ability to define these problems and answer them.
And that's true. That is true. And maybe we should do that because
Because it doesn't
uh,
feel, it feels like a job of reconciliation, not a
Yeah.
job of really figuring out. Like, I don't think there's any missing pieces from the puzzle set. Like, we've got all the jigsaw pieces, surely.
Yeah. And we've got tool calls out. Um,
Like network-based tool calls, yeah, yeah.
yeah. So,
So side effects, we've got
the
side
what?
effect tool calls.
Yeah. So the simplest um, possible thing is a single artifact node running the amber bit or encapsulating the amber bit.
Yeah,
Okay, let's
and
go
it's
there and
it's
then
it's really
we'll
just
use it.
like I wanted to take advantage of spinning up these extra VMs because that's just a great break point to put that kind of scale in.
Yeah, yeah,
And yeah, you could run all that without VMs and you could run it on one box, but now, that box has to get bigger and bigger and all that. So I liked having individual VMs. They're disposable, they're safe, they're isolated, they're
movable. Yeah,
yeah, recoverable. They can fucking conk out halfway through and you're like, oh well, we got the last snapshot, kick it off.
yeah, yeah,
So in that sense, I guess Artifact acts like a database more than the application layer, and it's you know, this tree here that's doing the application work,
yes,
maybe. But yeah, I just feel like we're so close to getting genuine, long threaded reasoning that if I can just see enough to get this basic thing off the ground, then we can use that tool in on itself, because you can't get answers to these questions right now using GPT-5 or Pro or Cursor or Codex directly, because you don't have this child of a child thing,
yeah,
and
yeah,
you don't have even sub agents, which are like agents that are tweaked and tuned and honed for a particular job. But that
yeah.
seems to be the key, right? Making these standalone agents and then naturally making a library that people can browse and share and update.
At that layer, this architecture absolutely works. Um, I can see how um, the provision thing, that's your part shit, but from the green hexagon layer, yeah, nothing more needed.
Yeah, it's like, and it scales like a motherfucker. It's like, well, they're pretty cheap, they're very abundant, they're worldwide,
Yep.
and they're kind of all yours. Like, you can pick the whole thing up and move it
Yeah.
somewhere else away from us, and
Yeah.
that's cool. Like, that's your stuff.
Yeah. So that part definitely works. And okay, so let's delay the bigger question about how we make that amber thing consensus wise.
Oh, I don't think that's a
Running.
problem at all. That's pretty easy.
Okay. All right. And the location of the running of the MCP.
The location of the running of the MCP
Or
server.
the call, an NCP call from inside of hexagon, green hexagon. At the moment,
If
could be done directly, or it could go through an artifact blob.
maybe it should go through Artifact, because, or maybe it doesn't need, if it doesn't change any state, then maybe it doesn't need.
Well, actually, an NCP call Uh, what state could it change? It's just going to inform it, and there's going to be an artifact call in order to change the state.
Yeah.
I don't think.
I think artifact is the correct place for the MCP calls to go through because uh, it it gives you guaranteed consistent in consensus state change. So if you're going to do a state change,
Mhm.
then that's the tool calls do there. If it's just read only, then you can just use your local node and that's all you need because you've got the
Yeah,
commit, you've got the path. But yeah, if you want state change, then I think that's what Artifact's good for. It's not for uh it's not for running an agent necessarily because that's too heavy a process, but for making a tool call that changes state, it's very good for running that
right, right.
because
Okay.
that's like thousands of little tiny things, whereas an agent is one big thing. And we can still subject the agent to consensus by making sure that others who ran it got the same repeatable thing.
Yeah,
Um, so that's all cool.
yeah. Okay. All right.
It's just yeah, there's a lot of different components. I'm convinced this is the best way to lay out the infrastructure. I'm also convinced that AI tooling will help us recompose this later. So surely the theory is get the AI tooling above all else. Make a crappy whatever you can manage version and then use the tooling.
Well,
I think
absolutely. I mean, in order to get it useful, we don't even need consensus. We just,
no.
we need one blob.
Yeah, and
Um,
just pay attention if it goes offline. We're like, whoopsie. But
yeah,
other than that, we use the tooling to redesign our system because it's like reasoning engines.
yeah,
How to reason heavily, like heavily reason whilst searching the web and all that, and then whirring off and doing these things, and then you'd be able to program these agents to fix all the little annoyances that we have. Like, I wish the tool would do this and that. And you're like, well, I'll set up an eval run or I'll tweak it myself or I'll do this.
yeah,
Like,
yeah.
I can't see how all the tooling that you've ever told me about can't be made inside of an agent.
Oh, yes. That's the leap. Everything up to and including attribution. Um, really, what we're talking about is, somewhere to store stuff, somewhere to reason about stuff, somewhere to set up how to reason about that stuff.
Yeah.
There's not much more to it than that.
Nah. Okay, well, I feel like this is the end. Like, this is our platform.
Yeah.
Because at that point where it can be used to improve itself, it's sort of it's away,
Yep.
and it's probably no longer ours at that point, but
Oh,
at
that'd be
least
a
it will
relief.
be.
Let someone else improve it, or let even better interactions improve it by the AI.
Yeah, hopefully itself can improve it. And I think what we've seen with GPT-5 is like, well, if we keep getting even linear improvements on that, like it's just gonna get better. So
Hmm. Been hearing a lot of claims about Grok 5, which um, appears to be even better, and it's coming down the roads.
yeah, I don't know about all that though, because OpenAI has got something that Grok doesn't, which is massive user base that they used to hone taste.
Mm-hmm.
Like just because the thing's right doesn't mean it's not a dick.
Yeah, yeah, but I like the fact that there's at least two,
Oh yeah, oh that's
possibly
great. Yeah,
three
and let's not write
in the
off
ring.
Anthropic either. Like Anthropic's
Well,
done
exactly.
really good so
Yeah,
far.
yeah,
Plus, there's all these government orgs. The Chinese guys are coming in. All this stuff.
yeah. But in terms of self improvement, if you take that as being largely similar to improving a system prompt, um, I think Grok's at the top of the polling on that at the moment.
For being able to improve a sysprompt.
No, for improving code or working on code, I think Grok is still at the top.
Is it?
Not by much.
I thought five had taken that prize.
No, they're very close, but I was looking at um, the latest benchmarks this morning, and Grok is still slightly ahead.
Which ones?
It was on a video. I can send you
Oh,
over by.
okay.
It was
Oh,
by
okay.
Wes
No, that's
Roth.
all right. Well, I think that's it, buddy. Oh, the other thing, sorry. Because these things are individual things running, I think we can actually route video through them. So you and I can have a group chat, and we've got some agents running, and then our video calls can go via them. So we can actually have, because we got this real live running process that's sort of on, we can do things like that now.
Ah, and by association, also audio, and we
Yeah,
could have that thing we've been wanting for ages, which is having an AI sit there calling out bullshit or
yeah,
fact checking or
yeah. So that's this system, and
yeah,
so our web page or our web app starts to look a lot like just helping you make really nice prompts using voice, using like context to, improve it and all that. And
right.
then task management, where it's just like, well, here's this task, here's that task, here's the graphs, here's the metrics. Do you want us to keep going? Here's the token burn. We can.
Yeah, that's my dream again. Never have to touch another keyboard. Um, just be able to talk to the thing like we do on Star Trek.
Yeah, well, I saw was it Boston Dynamics was doing a demo today of how you could teach the bot by doing your own movements. Like you're like over there, or like you show it how to do something with your hands, and it looks at it and watches, and that's how it learns. So that's how you program it,
Yeah, that's cool.
which is sort of like how you program another person.
Yeah. Um, I was seeing a demo of a webcam, which is a very simple way of doing that, where you put your hand up in an L and moved it up and down, and it zoomed in and out, which I thought was quite cool.
Right. Yeah, that's cool.
It's quite trivial, but kind of
Hmm.
cool.
I think the issue I had was just worrying about, maybe we should just in the meantime use GitHub directly rather than Artifact itself. So
I
I
wouldn't
don't.
I wouldn't go that far yet, but if it's the shortest path, yes, because getting the any kind of system up with the
That's what counts, eh?
you
Is like speed,
yeah,
raw speed.
it doesn't have to be the final thing at all.
No. Because each time one of these containers runs, it needs to pull down the latest Git repo.
Mm-hmm. Yeah.
That means that now I got to make Artifact able to be pulled from, because it doesn't right now. But then GitHub already does all that, and if you're just working on repos on GitHub, maybe that's less work. It's a pretty well trodden path.
Shortest path to getting, the hexagons up better.
Oh, God. And then artifacts just doing nothing.
Well, it's going to be called back in because
It's just going to take a little holiday.
yeah.
Fuck. But that's definitely not Dark Age. Look, I'll sort that one out. I think.
All right.
Yeah.
Yeah.
Fuck. It's all problems.
Yeah.
Anyway, I think that's all for me, buddy.
Yeah. Cool. Cool, man. Right. I'm going to go at this point.
All right.
I am fading.
Yeah.
Should have
Me
got
too.
more sleep last night.
Oh dear.
Probably should have as well.
Yes, I know. All right, I'll stop recording.
Okay.